Our next task is to figure what happens with cosine of negative theta with this negative argument. We're going to talk through the negative argument nomenclature, and then we'll talk about this even-odd nomenclature just a bit. So, cosine negative theta, what happens when we have a negative argument? We recall sine of negative theta, the sign is kept. So with sine, you keep the sign. Sine keeps the sign. That's my memory device I used as I was a student back in 19... Sine of negative theta is negative sine of theta. So the question is now, what happens with cosine of negative theta? Does it behave the same way? Well, it turns out no. And the reason is because if a point lies on the unit circle, cosine is the x-coordinate. It's x over r. Remember, r is equal to 1 on the unit circle. And so cosine theta is the x-coordinate. Let's see what happens here. If this is, look at cosine theta. If theta is here, when we drop this perpendicular, where in this picture, if this is the unit circle, where in this picture is cosine theta? Well, cosine theta is the x-coordinate. Cosine theta is that distance. But now when I make negative theta, it's the mirror image. So this is now negative theta. And what is the x-coordinate of negative theta? Well, we can see that the x-coordinate of negative theta and the x-coordinate of positive theta are the same. Both of them are a. So cosine of theta and cosine of negative theta are the same thing. Sine, the y-coordinates, the y switch from positive to negative or negative to positive. So the sine switches sign, but cosine remains constant. So the memory device has to be that sine changes sign, but cosine is constant. Cosine stays the same. Cosine of negative theta is a. Cosine of positive theta is also a. Cosine of negative theta and cosine of positive theta are the same. In cosine, the negative sign vanishes. Either memory device or flashcards or whatever it takes for you to learn that, but you need to know that cosine of negative theta is equal to cosine of theta. Sine of negative theta is equal to negative sine of theta. Now let's see if we get the same argument here. I think it should be pretty clear. In this scenario, when we drop the perpendicular, where in this picture, again assuming this is the unit circle, where in this picture is cosine of theta? Cosine of theta is the x-coordinate. That distance is cosine of theta. But when we make negative theta and drop the perpendicular, cosine of negative theta is also the x-coordinate, but it is the same x-coordinate. So this is cosine of theta. This is also cosine of negative theta. They're equal to each other. They're equal to each other. Cosine of negative theta and cosine of positive theta are equal to each other. So we have sine of negative theta is negative sine of theta. Again, when I was a student, sine keeps the sign. Sine keeps the sign. Cosine does not. All right? So that's the sine version, that's the cosine version, and then we'll talk about the tangent version next. Before we get there, the question might arise, what about secant? Remember that secant is the reciprocal of cosine, and the reciprocal of a number does not change the positive or negativeness. So the behavior of cosecant is the same as the behavior of sine. The behavior of secant is the same as the behavior of cosine. And when we develop the behavior of tangent, it is the same as the behavior of cotangent. So the reciprocal functions have the same property. That's why typically, and this is what I will do with you, I will only hold you responsible for sine of negative theta equals negative sine of theta. Cosine of negative theta is equal to cosine of a theta. And then I'll also hold you responsible for the tangent version, which we'll talk about in the next video.